Hello YouTube. Aircraft. At least one day in your life you saw an aircraft fly in the air, unless you have been living in the cave. But the question is how this machine is flying, or how this machine is staying in the air. In today's video we are going to try to respond to it. So let's start. We cannot talk about aircraft without talking about aerodynamics. And aerodynamics is just the study of air in motion, which includes some physical characteristics such as pressure and density. And the pressure is just force over an area, and the density is just the mass over the volume. Okay? And an object in motion in the air is subject to 4 forces, such as lift, weight, thrust, and drag. And if you take, for example, the thrust is just the forward force, the force trying to push an object forward into the air. Okay, for example, if you take a stone and you throw a stone, the thrust is going to be like the force that you are applying and you are throwing the stone into the air. So that's the thrust you give to the stone. Okay, and the drag is just going to be the reaction of the air over the stone. The stone is trying to penetrate the air, but the air have a reaction over the surface of the stone, which try to resist to this movement of the stone, right? That's the drag that we have. And now, so we can see that the thrust and the drag are just two forces that are opposite actually. Okay, the thrust trying to move in front and the drag trying to resist to this movement and bring the force, the object backward. Okay, so they are very opposite force. And now the lift is just for this simple experience that we have with a paper. For example, you have a paper like this. If you blow on the paper, you see that the paper have a tendency to move up. Okay, so that's the lift that we have on object. Okay, and we're going to explain this thing, don't worry. Okay, now let's continue with the weight. The weight is just the mass times the gravity, and we know this mythical experience of Isaac Newton, which was saying that so you have a force trying to attract the apple down on the ground. Okay, so we know this experience. But here with aircraft, the principle behind the flying of an aircraft is Bernoulli principle. Okay, Bernoulli was a Swiss mathematician and physician, and he was born in March 1782. Hey, I say Bernoulli principle. I didn't say Bernoulli. I'm not here to talk about history. The Bernoulli principle is working on something called the venturi tube. What is the venturi tube? That's a venturi tube. So in this tube, we have one principle applying, the conservation of energy. Okay, and this energy have in relationship 2 big factors, the pressure and the velocity of air. And we can notice 2 big parts in this venturi tube, a wide part and a narrow part. Okay, and in the wide part we have less velocity of air but high pressure. In the narrow part you have the opposite, a high velocity of air but a low pressure. So now you can notice the conservation of energy. Okay, so when the pressure is high, the velocity is low, and when the pressure is low, the velocity is high. Okay, now if you cut the venturi tube horizontally like this, we will have something like this. Okay, one part which is more curved and one part which is like flat. Okay, and the upper part which is curved, we can consider it like the narrow portion of the venturi tube, and the flat part we can consider it like the wide part of the venturi tube. So when we cut this venturi tube, we'll have finally this airfoil shape. Okay, and this airfoil shape is on a lot of parts in the aircraft. The stabilizer here have this shape, the wing have this shape, and the propeller for the rotary aircraft have also the same shape. Okay, we want to generate a lift, so we need this shape. that we call the airfoil shape. And this airfoil shape have 4 big parts. The leading gauge here, which is the biggest part, the trailing gauge, the smallest part, the upper surface and the lower surface. Okay, now by identification, we can know that the upper surface is the narrow portion of the ventral tube and the lower surface is the wide portion of the ventral tube. Okay, so let's say we take 2 molecules of air. They are here in the leading gauge at the same time, and they have to meet at the trailing gauge as well at the same time after they travel over this airfoil shape. One molecule of air have to pass in the upper surface and the other one have to pass in the lower surface. What will happen? You will see that the upper one have a curved path to travel, so more distance to travel. Okay, so now it will have to increase its speed to reach the trailing gauge at the same time as the lower one going at the lower portion. Okay, this one, the speed has to be normal, it's fine, it's going to go slowly, but this one at the upper surface have to travel more distance, so we'll have to increase its speed. And what's happened when you increase the speed? The pressure drop, right? So now the fact that all the molecules passing at the upper surface have to increase their speed, they are going to decrease their pressure, the pressure over the upper surface of the airfoil shape. Now here we have a low pressure and here we have a high pressure, and this pressure down here have this tendency now to push the airfoil shape up. Now we have generation of lift. And as we were saying before, there are a lot of parts on the aircraft which have this airfoil shape, okay, like the wings, the stabilizer, the propeller for the rotary aircraft. Yes, it's fun. And after this, what will happen? We need what? We need the other 3 forces, okay, applying on the aircraft. The thrust, and this thrust is going to be generated by what? The engine. Okay, the drag is what? When you move in the air, the resistance of this of the air over this whole surface of the aircraft will generate the drag, right? Well, fine, for the moment you're not moving the aircraft yet, you're still on the ground. So we need what? We need to overcome the weight of the aircraft. We try to bring the aircraft on the ground, keep it on the ground, right? So what will happen? We have the thrust moving just straight forward and the lift moving straight upward. The resistance of these 2 forces is going to be like this, just simply mathematics. Okay, so that will happen. That's why we need to give the power to the engine to bring the aircraft at a certain speed, plus the lift generated by the airfoil shaped surfaces on the aircraft, like the wing, the stabilizer and everything. Now the aircraft will have the tendency to move up, to overcome this weight. We try to keep it on the ground. That's how the aircraft flies. And we saw that we have some surfaces on the aircraft which have this airfoil shape, like the wing, the stabilizer, right? And now we need what? The other 3 forces are there: the thrust, the weight and the drag. The thrust is given by the engine, trying to push the aircraft straight forward. Now we have the lift that we saw on the airfoil shape. The wing will generate this airfoil. The wing have this airfoil shape characteristic. The stabilizer as well. And now they are going to bring this force upward like this. The resistance of these 2 forces, the thrust and the lift, is going to be like this, inclined like this. That's why the aircraft is going to take off. But to have this force which bring the aircraft up, we need to give a certain power. That's why when you take off, you go from speed 0 to a certain speed. And the machine is telling the pilots V1. After this V1, we have now the machine will tell the pilot rotate. This rotate is when the pilot is going to move the control wheel toward himself, and now it will give a certain pressure at the tail of the aircraft to push the tail down. When the tail is down, is pushing down, the nose have only one movement to go, upward. And now the wing are going to generate this lift plus the thrust. Now the aircraft take off. That's how aircraft are flying. I hope you enjoyed this video. Don't forget to let any comment, any likes on the comment section below, and don't forget to hit the bell to be aware of the upcoming videos. See you in the next one.